All right, this is an example we looked at briefly in class, but I want to go through it slowly as an example for you to follow. It says, find the polar equation of a parabola whose focus is the pole and whose directrix is y equals -4. So it does say parabola, and we can use that information right away to say that the eccentricity is equal to 1. For a parabola, the eccentricity is 1. For a hyperbola, the eccentricity is greater than 1. And for an ellipse, the eccentricity is less than 1. The directrix is also at y equals -4. This is 4 units away from the pole. We've defined P to be the distance between the directrix and the pole. So if the directrix is at y equals -4, then the directrix is 4 units away from the pole. And we are giving the equation of the directrices in a rectangular form, because to write the equation of that line, y equals -4, in polar form is obnoxious. Writing a horizontal line equation in a polar coordinate system is really obnoxious. It's just easier to say the directrix is at y equals -4. So P is the distance between the pole and the directrix. So P equals 4. So here's a bunch of stuff that I know. I've already talked about this one, parabola, because E equals 1. If E is equal to 1, then when I say E times P, we also talked just now about how P is equal to 4. It's 4 units away from the pole. So they graphed y equals -4 down here at the bottom in this red dashed line. And so we can see that if we draw that line as kind of a sketch of a graph, that that's going to be P, 4 units away from the pole. Then we can go back to our pattern of the general equation. And we have an equation that's going to be R equals EP over 1 minus E sine theta. If we know that the directrix lies below the pole, what we are trying to learn and remember is that when the directrix lies below the pole, we're going to use EP over 1 minus E sine theta. If the directrix was above the pole, we would change that to a plus. If the directrix was to the left or to the right, we would use cosine. And so then we're just plugging in all the values. E is equal to 1, P is equal to 4, we've got to plug in E twice, and we're finished with that problem.